Alright, so on number 1, here on the homework for Unit 8, number 2 homework, is to find the area of this shape. So I am going to turn it into a full rectangle. And the area of that rectangle will be the length, W plus 5/9. And we're going to multiply that by the width, which is 2/3 of width. Now, what I will do is distribute this 2/3 W into the parentheses. So 2/3 W times 1W would be 2/3, but it's W times W, or W squared. Then over here, we've got 2/3 times the 5/9, which comes out as 10/27. That's just the area of the whole thing, but now we've got to take away the area of this rectangle because it was an empty rectangle. Sorry, I forgot there's a W on this one as well, right? Alright, so let's figure out the area of that other rectangle. So it has a length of, we'll say W plus 1/3. And we're going to multiply it by the length, which is 1/9. Alright, so let's distribute the 1/9 into the parentheses. So that'd be 1/9 of a W plus 1/27. And we're going to subtract that from this expression. So we're going to subtract 1/9 W, and we're going to subtract the 1/27. So the only two parts we can combine on this are the two W parts. And this 1/9 would actually end up being 3/27. So I've got 10/27 W minus 3/27 W, which would give me 7/27 W, which is positive. Then we got this 2/3 W squared, and also this negative 1/27. That would be considered the area of that shape without that green rectangle right there. Now we can't combine the W squared because it's a different number of W's than that one right there. This one wants us to find the area and the perimeter of this shape. It looks like the length of this line radical is 4.52. So that's what we will assume on these. So let's go ahead and we'll find the area first on that. So the first thing I'm going to do is find the area of this rectangle, which would be 12x times 4.52, which would give me, so we got 54.24x just from that part, but then we also have this half circle, which if I combine with this half circle will give me a full circle. So that area will be the radius, which is half of 4.52. And the radius here is going to be 2.26, whatever the units is. I'm going to round that to 16.05 actually. Now, to find the area of the whole thing, we just need to add these two together. Alright, so let's add these two together. As it turns out, we can't combine those because they're not like terms. So the area of the entire shape ends up being 54.24x plus 16.05. Next up, we need to find the perimeter. And we can see this length here is 12x. And this length radical is 12x. And then we've got this circle, which has just been cut in half. So we've got the two 12x's for the perimeter. But then we've got we need to find the circumference of that circle, which would be the diameter, 4.52, times a pi. So let's go ahead and simplify that. The two 12x's give us 24x. And then we're going to add that to 4.25 times pi. We'll round that to 14.2. And that would be what we would call the perimeter right there. So we have our two answers on that. Perimeter and area. All right, 3, we've got this plot of garden for Jeremy, or this garden, whatever. We want to find the area of it, and then we got to figure out how much cubic feet of soil he'll need if he wants to cover this area with 6 inches of soil. Then we will figure out how many cubic foot of soil he'll need to purchase. If he covers the area with 1.5 foot, okay, that's different. How many foot of fencing will he need to enclose the garden if he fences this exact shape of the garden? That would be the perimeter of this shape. So first, let's go ahead and find the area on part A. So the area, I'm just going to treat this as though it were a full rectangle. So that would be a 14 by 10. So that area is 14 times 10, which is 140 square feet. Next, we need to subtract out the area of this rectangle, which is a 6 by 4. So that's 24 square footage. And the area of the shape that we originally had then is 116 square feet. All right, B, how many cubic foot of soil will we need if he covers the area with 6 inches of soil? We got to be careful on this because we've measured the area in square foots. So when we look at B, we're really looking at 1/2 of a foot. Now, and if we want to find that volume, which would give us cubic foot, all we need to do is multiply that by the 116 square feet, and that will give us feet cubed, and that appears 1/2 times 116, looks like it would be 58 cubic feet of soil. Let's go to C then. How many cubic foot of soil will he need if he buys or covers the area in 1.5 foot of soil? So now, instead of 1/2 foot, we're looking at 1.5 foot. And we're still covering an area of 116 square foot. So we're just going to multiply these together. And this again will give us cubic foot. That would be 174 cubic foot if we want the depth of the soil to be 1.5 foot instead of 1/2 foot. Part D, this one is simply the perimeter of this. So let's go ahead and go through the shape though and identify what all the lengths are. So this is 4 foot radical. If that's 14 foot and that's 6 foot, then we got 8, so this is 4 foot radical, 4 foot radical, and 10 foot. So let's go ahead and add all those together. So there we go. And the final perimeter after we add all of these, so the perimeter appears to be 56 foot. Number 4, Nico is building a deck around a circular poo in his backyard. The poo has a radius of 15 foot and the deck will be 5 foot wide. So we want to find the area of the deck. Looks like that's all there is on this question. So the first thing we want to do is find the area of this outside bigger circle. And this one has a radius of 15 but then an extra 5. That's a radius of 20. So 20 times 20 times a pi would give us the area of the poo and the deck. So this appears to give us, I rounded this to 1,256.64 square footages. Now, that was the area of the whole thing, but we're going to subtract the area of the poo. And that area is given by a radius of 15, so 15 times 15 times a pi, which gives us, alright, so this is the area of the smaller circle, which is also the poo. So let's go ahead and subtract those. So subtracting these two, and I get 549.78, and this would be in square foot for the deck. That's just the deck area of Radical.
What are you pointing at?
5A, a stage with a trapezoidal area, upstage, and rectangular area downstages illustrated in this figure. That's very nice of them. Find the area of the stage. Alright, so let's look at the area of this thing. So there's a couple things you could do on these. And yeah, let's go ahead and do what you guys suggested. Let's change this into a rectangle. So this area would be 5 times 48 radical, which is 240 square footages. Next, what I'm going to do is I'm going to take this off radical, this portion. Now we could have figured it out using the area of a trapezoid, but we haven't really looked at that too much. And if we can focus on triangles and rectangles and circles, then hopefully it's not too much information. But I've got this rectangle radical, which gives me an area of 35 times 21, which really is, alright, and there we go, 735 square foot. Next up, I'm going to find the area of this green triangle, and it's going to match this triangle as well.
Did you just put those together?
Yeah, that's what we got to figure out. So we can see that it has a height. The triangle for the area, it has a height of 35 foot, and we will be dividing this by 2, but we're going to have 2 of those. But what we need is this bottom length radical. Well, the total length is 48, but 21 of them were taken off because of the rectangle. So that left us with 27. Yeah, 27 between the 2 parts, this one and this one. So one of the lengths would be 27, but we're going to divide that by 2.
How do you know how?
Yeah, that gives us 13.5 as a base on this. So that's going to be my base value, 13.5 times the 35 divided by 2, but then times 2 because we have this other triangle radical. Yeah, so the area of both triangles is 472.5 square foots. So we're going to take those and add them, all 3 of those, the green, purple, and reds. And when we add all these together, we will have the actual area of the whole shape. So adding these together, 1,447.5 square feet. Rachel is painting a new sign for the new health center. Find the area of the sign that she will need to paint red if she paints the entire area red. Alright, so we're just looking at the area of this whole thing. That's not too bad. And then we'll look at the second part. Suppose Rachel decides to paint a lower portion, the 3x1 bottom portion, shown below the dotted line of the sign, a different color. Then what portion would be that color? So let's find the area of the whole thing, because we're going to assume that Rachel's going to go in and paint this whole thing red, radical. But she'll stay in the lines, hopefully.
Looks
like vandalism.
So what I'm going to do on this is I'm going to treat this like a full rectangle, which would have an area of 3 times 2, which is 6. Now if I can find the area of each of these triangles, then I'm just going to subtract, and there's 3 of them. Now what they did give us was the base of the triangle is 1, and the height is 1 meter. So if I want the area of one of the triangles, I've got 1 times 1, but divided by 2. That's 1/2. But we've got 3 of those, so I'm going to multiply that by 3, which would give me 3/2. So I'm going to subtract that from the 6, my 3/2, and that would give me 9/2. And that would be in square meters. So that's the area of the sign. But it's saying that what if she cuts it off radical and then paints this rectangle purplish color? Well, the area of that is a 1 by 3 rectangle, which is 3. So what percent of that would be that horrible purple color? Well, we're painting 3 of it, that horrible color. And the whole area is 9/2, so we're going to divide this. Divide it by 9/2, which would end up being 3 times 2/9, which would end up being 6/9, which simplifies into 2/3, I guess, percent, so that would be 66.7%. Of it would be this purplish, perverted purple color. Wallpaper comes in rolls that are 60 foot long and 2 foot wide. How many rolls of wallpaper will it take to cover 700 square foot? So each roll, one roll, is going to cover 120 square foot. And what we want to do is cover 700. So we're going to take 700 square foot and divide it by 120 to see how many rolls we need. So this is 5.83 rolls, but they won't let you purchase 0.83. So we're going to need to round this up to 6 rolls.
If I got it right.
A rectangular garden has an area of 45 square feet. If one side is 6 foot, then what's the other side length? Alright, so let's draw this out. So we know the area is 45 square foot, and one of these sides is 6 foot right account. So the area is the length times the width, and right account, we know the area and the length. So the area is 45, and that length, or width, what it doesn't matter what you call it, is 6. So we'll divide both sides by 6, which gives us the width at 45/6. We can round it though, I guess. So that's 7.5 foot, which is A. Well, we want to put a fence around this thing, so how much fencing would we need for part B? That's the perimeter, which is going to be 6 plus 7.5 plus 6 plus 7.5, which would give us a perimeter of 22 feet, and that is part B. You decide you want to increase the length of each side by a scale factor of 3.2. What are the new dimensions of the garden? So we got length and width. The new length would be 7.5 times 3.2, which is 24 feet, and the width is going to be 6 times 3.2, which is 19.2 feet, and that is part C. Then what is the area of the new garden? So 24 times 19.2, which is part D, 460.8. This would be in square foots. And there's all 4 parts of that one. Miss Garcia has a table shaped like an isosceles trapezoid. The 2 parallel sides have lengths of 6 foot and 8 foot, and that's what makes a trapezoid. A trapezoid, it has 2 sides that are parallel like these two. This one will be 8 foot, this one can be 6 foot. And we've got these 2 sides as well. It says that the height of the trapezoid is 4 foot, which makes a right angle radical. What is the area of the top of this? So we're just asking what the area of this thing is. So if we cut this thing up into 2 triangles and a rectangle, that would give us 4, that's 6, so that's 1 foot radical. That's 1 foot. And that's 6 foot. So the area of this middle portion, radical, is going to be 6 times 4, which is 24 square foot. And then we got this triangle and these, which we could change into a rectangle. That would be a 1 by 4 rectangle. So that area would be 4 square foot, which we will add to the 24, and we find that the area of the table is 28 square foot. That is part A. B, suppose Miss Garcia has 1.7 foot, a 7.5 foot by 0.8 foot puzzle on the table. How much surface area is now available on her table? So we have 28 square foot, and we got to figure out the area of the puzzle, which would be 1.75 by 0.8, which is 1.4 square feet. So we're going to subtract that from 28, and that gives us the area of the rest of the table with the puzzle on top of it. So that's 26.6 square feet with the puzzle on top of the table. Your neighbor's backyard lawn is shaped like a rectangle. The back fence is 38.2 foot long, and the side fence is 32.6 feet long. He will pay you $0.04 per square foot for mowing and 11 cents per foot for trimming all the edges. How much will you get paid total for mowing and trimming? So, in this lawn, it told us that the back fence was 38.2 feet and the side was 32.6 feet. So, we need to figure out how much area this is. So we're just going to do 38.2 times 32.6. So about 1,245.32 square foot. And we can see that he's going to pay you 4 cents for every square foot. So we're going to take that value, 1245.32, and multiply this by 0.04. That will tell us how much he's going to pay you. So about $49.81 for the mowing. Next up, we got to figure out the perimeter of this thing. So we've got 38.2 and 32.6. So that's all 4 sides, which when I add together is the perimeter. So this is 141.6 feet. And now we'll multiply this by the 11 cents for every foot, which is, so there we go. That's $15.58 for the trimming. Let's just go ahead and add that to our $14.81. So as a total, you would have been paid $65.39 for the mowing and the trimming.